All right, chemistry class, good afternoon. Here's a bonus lecture you can watch if you want. I figured, we haven't hardly talked about hardly anything in this class, due to earthquakes and, COVID and then me taking over the class and you guys not knowing, being rusty on your skills. So I wanted to talk about behavior of electrons. This is a bonus lecture, okay? Because I feel like we just talked about the dual nature of light, but that plays into the way electrons behave, okay? So I want to talk about this. And yeah, it's way more detailed when you look at any system, but that can also make you confused depending on how you look at it, okay? So first we want to look at Bohr's theory, okay? So we knew the light was dual nature, right? Both a wave and a particle, but they still didn't know how electrons behaved. So how does this tie in? Well, we'll get there, okay? So Bohr was a famous scientist, okay? And he proposed that the hydrogen atom has only certain allowable energy states. Okay, so you can see here, or maybe you can't see, I'll send the photo, okay? But he basically said that there's different states of energy and the electron can hop between the levels. And he also said that electrons move in a circle around inside the atom. They move in a circle and they can jump energy levels, okay? And what it said is it absorbs, when electrons change energy levels, it either absorb a photon or release a photon when it's changing between energy levels, okay? So he was onto something, so basically we have ground state where the electron is closer to the center and a side state where the electron is further out, okay? So that's a good start. He was onto something, but it didn't work for any other element. This only worked for hydrogen, okay? So he said the electrons move in circles and they can hop up and down between energy levels, but this didn't really seem to work for any element besides hydrogen. And electrons, just so you know, they don't actually move in a circle. Okay, they don't just move like a planet orbiting the sun. That's not how they go. Okay, they're a lot more complex. We'll get into that. Okay, I'm not here to talk all day. I just wanted to. This is important. You guys know a little bit about this. Okay. So next came Louis de Broglie. That's French. You could probably say it a lot better than me with your French skills. Okay, but he was like, can particles of matter behave like waves? Okay, so since particles of light can behave like waves, can particles of matter behave like waves? And his answer basically was yes. And he came up with this equation, which I wrote this here, but you don't have to do anything with it. It was more just so you see it, okay? But it has wavelength, it has Planck's constant, which we saw in the last videos, right? And mass and velocity, all things you guys know what they are. So we used this equation to predict that all particles have wave characteristics. So basically he was like, electrons have wave characteristics too, even though they're particles, even though they're not light, okay? So that's big time. And that brings us over here. So basically, they're trying to figure out, he's like, well, it's really, when you read it in a system, it's very confusing. It's like, he's like, oh, the electrons are moving in these wave-like formations, okay? But then we come to Heisenberg, okay? Heisenberg's very important. And he came up with this Heisenberg uncertainty principle. So what he showed, I'm trying to explain this, okay? Heisenberg showed that it is impossible to take any measurement of an object without disturbing the object. Sorry. Impossible to take any measurement of an object without disturbing the object. So the example, this is a good example, okay? So you think about if you're in a dark room, pitch black, and you can't see anything, and you're trying to find a balloon. Okay, the balloon floats. You're trying to find the balloon, and you're in the room and it's pitch dark. When you touch the balloon, you'll know where it is, right? But when you touch it, it also will move. So then when you find it, if you only touch it with one hand, you'll keep touching it and you'll keep knowing where it is, but it will keep moving every time. And that's what Heisenberg was saying. It's impossible to take a measurement of an object without disturbing the object. So if you're measuring an electron, you won't know, it'll have to move. You won't know where it is. This is anything. If you touch it, it's impossible to take a measurement without disturbing the object. So it's like you go to touch the balloon in the dark, it's going to move. Okay, so then the Heisenberg uncertainty principle, okay, states that it's fundamentally impossible to know precisely both the velocity and position of a particle at the same time. Okay, so for electrons, you can't know how fast it's going and where it is at the same time. So if you know how fast it's going, you don't know where it is. If you know where it is, you don't know how fast it's going. It's very confusing. I'm just introducing this so you understand how complex electrons are. So we still really don't completely understand where electrons are all the time and what they're doing, okay? But we know that you can't know the position and the velocity of electrons at the same time, okay? Very confusing, all right? And so then that brings us to Schrodinger. And he came up with a quantum mechanical model of the atom. where electrons are treated as waves. And obviously I can't draw this stuff. Okay, you look at any system, they kind of draw it. But basically, electrons are treated as waves. So they're particles that are treated as waves, a lot like light. That's why we talk about the dual nature of light first. So that way it makes sense that electrons can behave as waves, since light behaves as waves as well. Okay? So then we get into atomic orbitals. And an atomic orbital describes the electron's probable location. And here's an example. You see how there's more dots around the center towards the nucleus and less around the outside? It's more likely that the electrons are towards the center of the atom in this case. But we don't know for sure. It's just more likely. Okay, so there's more likely, and then there's a greater percentages. You would say it's like 90. There's lots of different percentages out there. You would say 95%, 90%. Likely that it's in this area, right? If this is an s orbital, we'll talk about that in a sec. It's more likely that it's towards the center, but you don't know for sure. The electrons could be outside. We don't know exactly where they are. Okay, but the odds are they're closer to the center, depending on what the model is like. And that brings us to electron cloud. That's what we have here. Electron cloud is where the electrons are most likely to be found. So a cloud basically means there's lots of electrons, and it's in there somewhere. They're in there somewhere. We don't know exactly where. We don't know exactly how fast they're going. Okay? And then we have different orbitals. So here, this is an S. So you'll see this in any system if you look. This is an S orbital. This is a P orbital. So basically, this means that the electrons can be moving in this S in the circular shape, and they can be somewhere in there, but we don't know exactly where. But an orbital is kind of a probable zone. It's a high likelihood that the electrons are in there somewhere. And then you get to more complicated orbitals. These are p orbitals, and it moves in like a figure eight shape. The electrons are moving in a figure eight shape, around and around, and they're in there somewhere, but we don't know where. But they're just doing that all over in the place, really fast. We think in the atom. Okay. So then there's different axes, the Z, the Y, and the X. This is all very confusing. I really just wanted to introduce these things. So it's hard to know exactly where electrons are. And so when you learn about things like this, for me, I feel like it reinforces my faith. Because it's very confusing, and you're like, well, how can we explain? Like, lots of science is just trying to figure out sorry, you can see me. Lots of scientists trying to figure out the way God created things and the way God made things. And a lot of it we can't necessarily explain very well. And so for me, that's like, well, we don't necessarily know it because God made things really complex, so we just can't figure them all out. Even though lots of scientists are like, well, God's not real, we have no evidence of him. But it's like, where did all this stuff come from? Who invented electrons and who put them in there and who put them in their orbit? Well, that's God. And it's very hard. Yes, we could argue maybe you guys don't believe in God, but I do. And I think, at a Christian school, that I think this is something you can think about, and you can read about more about this. But science is a very good look into the way God created things. So all that to say, the reason I'm talking about this stuff is I didn't do the best job explaining that because it's really confusing and you don't have any homework. I more just wanted to introduce it. Okay, so we don't know where electrons are in the atom, and if you know the position, you don't know how fast it's going. You know how fast it's going, you don't know the position, and it's kind of in like a zone, an orbital zone, where we think the electrons are, but we don't know exactly. Okay, but all that to say is that God knows where the electrons are because He made atoms. So I feel like the more you learn about science, the more you can learn to see how God works, in a sense. It's very confusing. And there's some things we don't know because maybe God didn't intend for us to know them. Okay? So, hopefully you guys look at this and you're like, wow, that's really cool and very confusing. Lots of science is very confusing, but that's how it is. God didn't just build this world real simple. He made it very complex. Okay? So I just wanted to say that. And the behavior of electrons is very confusing. So, yeah. But for me, things like this that you'd hard to understand, it just reinforces your faith more. At least in my case, okay? So that's something to think about, and I'll see you in the last video. Say goodbye.